Welcome back to Algebra 1, Chapter 8, Section 5 in this book. What we're going to talk about this time is a formula for exponential growth. When we get to Algebra 2, we'll learn some interest formulas that are more complicated, but this is a good introduction of how these growth formulas work, okay? So, first of all, remember we put an exponent in our calculator to see what the graph looked like. And this is just the positive axis. You know, I don't have all four quadrants. I just have the positive one. And if we start off and something has exponential growth, it makes that swoosh up. And remember I told you it gets closer and closer to the axis without going away, which is called an asymptote. That's fun to say. All right, so here is our formula. Y equals C, beginning parentheses, 1 plus the rate times raised to the time power. So C is how much you start with. A lot of times it's P. This formula, they'll change how it's written, and it stands for principal, or what it means is how much you start with. I like P better because C looks too much like a parentheses to me, and I can get confused very easily. The rate, you write it as a decimal. And the time, the exponent is whatever time it has. So here is a problem. You start with $500 and you put it in the bank, and it's going to grow 8% a year. Woo! So that's a very high rate. You don't get that in a bank nowadays. I don't know where that bank was. But anyway, we're going to leave it in there for 6 years and see how much money we have at the end. Every time I want you to write your formula, that's going to help you memorize it. So write Y equals C, beginning parentheses, 1 plus R, in parentheses T. Our C is 500, and then 1 is 1 plus is plus, and our rate, written as a decimal, is 0.08. Remember how you do that? It's got 2 zeros, so you go 2 places over, and it becomes 0.08. Now, if you added these together, it'd be 1.08. So sometimes you see it written like that. This is a growth because of that plus right there. If it was a decay, if it was getting smaller instead of bigger, it would be a minus sign. And because this is a plus sign, it's a growth, something plus 1, it's always bigger than 1. If it's a decay and it's minus, then it's less than 1. So, all right, and then we put it in for 6 years. Now, you can put this exactly as written in your calculator, hit enter, and you will get the answer. And, you know, just put it in. 500, beginning parentheses, 1 plus, 0.08, in parentheses, up arrow 6. Enter, and you get that. But this is money. And so we won't use that 7 because money only goes to 2 decimal places. Pennies, or this would be 43 cents. Now your book said this would round up to 793.44. From what I understand, banks do not round up. That they would give you just 0.3. I'm not a banker, I don't know, but that's what I heard. All right? So if some of you have banker parents, you could ask them. All right, so here's another one. We start with a catfish that starts off weighing 0.3 grams. They grow at 10%. At a rate of 10% in exponential growth, and we want to know how big it is at 6 weeks. But the catfish doesn't just grow once a week, it grows every day, so we need to change those weeks to days, and how we do that is with the conversion factor. First, you write down what you know, you write the unit of what you know on the bottom, the unit you want on top, and then you write the relationship. There's 7 days in 1 week. Any number on top gets multiplied, any number on bottom gets divided. So 6 times 7 is 42, divided by 1 is 42. The weeks cancel out and you're left with days. So now we put it in our formula. 0.03, beginning parentheses, 1 plus 0.1, because 10, go 2 times, is 0.1, up to the 42, and you should get that. Try each of these on your calculator and make sure you can get the answer. Here's another one. You start with 20 rabbits. They grow at a rate of 3 times as much. So that, and this is our total. So it's 1 plus 2. 2 is our rate. They grow really at 200%. but we'll do 1 plus 2 there, and we want to know how many rabbits we have after 5 years. 4,860 rabbits, growing like rabbits. Maybe I need to go into rabbit farming. I don't know. All right, math is great. See you next time.